under the sky to save me. Look into the sign of life. Looking through something to help me burn out bright. I'm looking for a complication, not looking 'cause I'm tired of lying. Make my way back home and learn to fly. Okay, that's the beginning of a new episode of Anycast, in which we're going to talk about deploying Rails application to fly.io. So, what is fly.io? Fly is a modern deployment platform for web applications focused on geographical distribution of your application, close to your users. Reduce latency by putting a server as closer as possible to your user, like geographically. And that's great. And they provide all the tooling to make it as easier as deploying a regular application on other platforms like Heroku, which is actually the reason why I'm here and their net chapter, but not going to talk about it. Let's talk about Fly. So we have a Rails application, our Anycast demo, and we haven't deployed it anywhere yet. So let's do that and let's try Fly. If we take a look at the Fly official documentation for Rails, we can see there are two options. You can migrate from Heroku, obviously, and you can use existing Rails app flow. This is our use case. Let's try to go with it. And the good thing is about Fly, it's kind of a developer-focused platform, which means that you can do everything using a command line utility called Fly, which could be installed with Homebrew on macOS or downloaded as a binary. Well, check their documentation. So all we need to do is to call fly launch in our application and see the magic happen. Let's try to call fly launch. Okay, and see what's going to happen. So a Rails app is detected. Right, we're using Rails here. Let's go with anycast.toml. I'm going to choose anycable organization. Here we first see the geographical aspect of Fly, so we can choose between different regions. Let's choose the one that's closer to me in New Jersey. Would you like to set up a Postgres? Yes, sure, that's awesome, because we use Postgres. Of course, we don't want to pay for it. Okay, waiting a bit while the database is being provisioned. Nice, it's here. Let's take a look, something went wrong. Connect to Postgres. Okay, yeah, that's the important part. The following secret was added. So Fly automatically adds database URL to the secrets of our application, so we don't need to do that manually. That's great. So your Rails app is prepared for deployment. We're using Ruby 3.1, Bundler, Node.js. Okay, what happened? Ruby versions available. This is something like, this is cryptic. Here we see that Fly is using Evil Martian's full stack Ruby Docker image as a base image for the application. Let's take a look at the Docker file actually. So here we use Ruby version variant. Here Ruby version is 2.7, which is definitely not what we're using. Okay, let's take a look at the fly.toml, the configuration that was created when we ran the launch command. And yeah, okay, here we see the build args, the ones that used in the Docker file. And here is a strange thing. Our Ruby version contains the restriction operator, which I think was inferred from the gem file. And if we take a look at the error again, we see that it wasn't able to find a version. I think that's because the build argument is wrong. Let's change it and call fly deploy this time. Okay, yeah, now we build in the image. While the image is being built, let's take a look at the configuration of the Fly application. So we already learned this is build args. And the way the app is built is using Docker files. As far as I understand, under the hood, Fly platform doesn't use Docker itself, but it uses Docker as a packaging format. I don't think we need to take a lot of care of reading through the Docker file. Let's assume that it's perfect for production. Let's take a look at the configuration instead. So we have a deploy section with release command. This is similar to Heroku release phase. So anything that's called right after the build was prepared, so the image or whatever was prepared, but before the app went live, is called here. And if it fails, then the app is not going to be available to users. Then we have environmental variables. These are two that are used by the Docker file, I think, and the services definition. This is actually kind of our HTTP layer definition. We have these checks, which port to use for the internal app, our Rails app, which is configured here for the port environment variable and should match. Some concurrency settings, we're going to learn about it a bit later. Ports to expose to the external world, like to public. So we expose both HTTP and HTTPS, but force redirection. That's good. That's a great practice. And additionally, we have a static path. So static assets are served not through Rails, but through some internal networking layer, like some proxy or whatever. I don't care. It just works. At least it should. So we waiting for our app to be deployed. Few things I want to add to this configuration while we still been waiting for it to be ready. And that I would like to start with pure action cable deployment. Let's take a look at our cable YML. And we have this special environment variable, action cable adapter. It's set to any cable by default. Let's switch it to Redis here. Okay, but we don't have Redis yet, right? Let's create one. I'm referring to that action cable official documentation on how to add Redis to our stack. Let's take a look. So Jam is already included. So we can just go fly Redis create. Okay, let's do that. Okay, in the meantime, our app being provisioned, we see that migration command completed successfully. Yeah, it's any cable, choose a database name. I don't care about the name. And that should be, okay, tricky. Dallas, okay, here we go. No need for replicas. I'd like to enable eviction. Well, for action cable or any cable, we don't care about eviction because we don't store keys. We only use PAPSAP features, so it doesn't really matter. 100 megabytes of data, definitely enough for us. And yes, Redis is here. And we have this Redis URL set, which we probably should add to our distribution. For that, we can use secrets. Okay, we're setting our Redis URL. Turn deployment, it's being deployed. Now let's take a look at our cable YML one more time. Here we don't use Redis URL anywhere. We should explicitly define it since Rails action cable does not use Redis URL and variable by default. Okay. I think that's it. Let's wait for Redis URL to be provisioned. And I think we will be able to deploy our app. And it should just work. Okay, let's go fly deploy again. This is a dashboard of Fly organization. We have three apps here. One is Anycast Demo, the one we created. Another one is Anycast Demo Database, which is kind of a separate application managed by Fly for us. And there is also Fly Builder, some internal tool which is responsible for building images for us. So it's also a Fly application. That's good about Fly. They do not use some hidden internal infrastructure for all the utility tasks. They just use their apps. That's great. So if we take a look at the app, we see some basic data, data transfer, memory used. In the monitoring tab, we see, okay, our logs, first of all. That's great. That's useful. What else? We have some basic metrics. No data yet because we haven't even opened our app. And there are a lot of other settings like scaling, certificates, activity, whatever. let's open our app. For that, we can call fly open. Yeah, here we go. Oops, but we don't have any users in our database, and we don't have a registration functionality yet. We just used seeds, right? Let's try to run seeds. Let's go back to the documentation. Here we have Rails tasks. Okay, that's probably what we need. Let's try. So it's connecting to our app and it fails. Well, not going into deep of this problem, but we can see that no rake file found. And that's because that db seed command is actually rake command, and it's looking for a rake file in the current working directory, which is not our Rails working directory, because it's like a root directory of our kind of image or instance, and it's not app. We could try going cd app and calling the command, but cd command is not available on Fly. So yeah, I think they're going to be fixed soon. For now, we can just open SSH console. Here we're inside our app, go app, and here we can call db seed. Okay, let's wait. Yeah, nice. We can call console here as well and see that we have some users. Okay, and we have some channels. Awesome. So we have users and channels, and now we're ready to log in into our application. Let's do that. I have a user called Vola89, and the password is pretty obvious. Never. Okay, I'm inside. It seems to work. To make sure it works and use Action Cable, let's open the second browser and log in as Alice. Alice is here. Never remember this password. Ping. And well, it's not present here as well. Okay, let's check our monitoring and check our logs. Oh, unauthorized connection attempt was rejected. What? That's kind of strange. Probably our first browser hasn't been authenticated. Let's check its browser tab. Okay, we don't have welcome. Why? Okay, yeah, it works. Let's check one more time. Pong. Oh yeah, that's probably because we had a stale version of our web application, or probably maybe our token has expired while we were deploying seeds. And now when we reload it, everything works fine. So our Action Cable version of the app just works. And we haven't did anything special about it except from creating Redis instance, and that's it. One thing I would like to try here is to do some performance testing. So how good Fly is at scaling WebSockets. You can learn more about testing WebSockets at our Evil Martians Chronicles and the post called Real-Time Stress, which introduce K6 and XK6 plugin for it, which we're going to use today, and as well as some instrumentation tips for using Yabida with any cable. So please check it out. The link is going to be added into the description of this video. I prepared a connect script, which only checks that we can handle a specific amount of WebSocket connections, but without really sending messages to them. So all it does is opens a channel page for the specified channel ID. Then it parses it to extract a cable URL, which is located in the meta text of the HTML page. Then it's called cable connect, which is from the XK6 cable plugin. Check that it's successful. And finally, it tries to find a turbo stream on the page. Well, at least one. We are only looking for the first one here. And subscribe to it and make sure the subscription is successful. Then we wait for the specified amount of time while we're trying to add more connection and see and measure all this interactions. So connection time, subscription time. I'm using .env kind of configuration to specify variables for our scenario, because we need to know the channel ID, the user's IDs to use to connect to authenticate. And we can specify the URL as well to test against. This is the URL of our homepage of our application. So this is our case 6 run case 6 connect, and let's specify our URL. It's going to be https anycast demo fly dev, and let's specify the time to wait for a connection before disconnect. Let's make it quick just to make sure everything works. Okay, let's run. And yes, our test scenario data is correct, the URL is correct, everything is correct. We can log in and authenticate. So let's do some stress test, and let's increase time to, say, 30 seconds. And one thing to note is that we use externally controlled scenario, which means we can dynamically increase the number of users. Let's run it for 30 seconds for the first time, and let's see case 6 status. It says the number of views, virtual users, is 1. We can scale it to, say, 20. Yeah, and 20 appears here. And let's scale it to 50. And finally, let's scale it to 100 while we're still here. And let's wait for the test to end to see the results. Okay. It's waiting for connections to complete. And this is interesting. So we have only 23 messages received, 23 sessions created, which is not really 100 like we expected. Let's take a look at our fly logs. If we scan for our logs, we could find these warnings. Instance reached connections hard limit of 25. What is that and where it comes from? It turned out that it comes from our fly config, from our services definition. We have this concurrency set to concurrency limits, hard and soft, set to 20 and 25. Okay, let's try to increase them like 2000. Why not? And deploy our app again to retry our benchmark. This is probably the first thing you need to change your configuration if you plan to use WebSockets, because 25 is definitely not enough for real-time applications. If you expect more than 25 users, of course. Let's retry our test, and this time let's make it a bit longer and try to connect more users. Let's try our scaling with 15. Oh, so we tried to reach 1000 and now it doesn't seem to work anymore. Let's take a look at our monitoring tab and see the logs. And we see that there is a problem with Redis actually. Connection to Redis has been lost. And we see that our server died and it's being restarted. Now we're trying to reconnect again. Let's try to switch to async adapter for action cable, for example, just to make sure we do not depend on free Redis instance, which is being crashed during our benchmarks. Let's try to see how much can we squeeze out of the Fly application instance using async action cable adapter, which is not kind of a production solution, but it's still worth exploring, since our bottleneck in the Redis version was Redis itself, not action cable or Ruby. Oh, so we see the problem starting to appear at the number of 1000. So we probably went too fast. Okay, let's try to add more. Oh, but handshake, that sounds bad. So this is about, okay, this is our result. So we were only able to create 672 sessions, which is not the amount of virtual users we created. So more than half of them just didn't make it. And we see that HTTP started to fail and successful connection rate is still good. The timing is kind of a good too, like seconds for connection is pretty good. Let's take a look at our logs in the monitoring dashboard. Why did we fail? What was the reason? Out of memory. Okay, we weren't out of memory. That's kind of expected. Let's look at our metrics tab for the last 5 minutes and see what do we have here. So yeah, this is our concurrency tab. So we see that we reached 1,500 at least connection attempts. And yeah, that's where we reached the peak CPU usage as well, 1.0. So CPU was busy. And that's why we failed. But we see that only 672 successful connection was made. So this concurrency means that our benchmark client tried to open a connection but failed. And that's what we see here, bad handshake. We can say that we reached probably 700 connections and we started to fail after that with action cable. I think it's time to talk about AnyCable, how to use it on Fly. There is an official documentation on how to use AnyCable on Fly. It's kind of in a beta state and it's going to be updated, I guess. But the one thing that makes me think that we should definitely think of better ways of deploying AnyCable to Fly is that the current documentation says it is impossible to run AnyCable alongside a tiny Rails application on 256 megabyte machine, which is true. We would probably able to run a small app with AnyCable go along it without RPC, which is our case. We're using RPC-less application on a single machine. But the question is, do we need a single machine and this complicated setup with custom Docker file, custom proc file, Foreman, Nginx? I think we can do that better and leverage the fly.io specific capabilities. And let me show you how we can do that. So instead of trying to put everything into a single kind of a Rails Fly application using separate processes or whatever, and using reverse proxy, I suggest going a different way and deploy AnyCable WebSocket server, AnyCable Go separately. That not only gives us an ability to kind of not hit the memory usage limit over free Fly tier for a single app, but also gives us all the benefits of using AnyCable and especially disconnect-less deployments. Because when you put everything into a single Fly app, you should restart it to get all together. You cannot keep WebSocket server running while restarting your Rails or Ruby code. And that's not good. Like we can be disconnect-less during deployment with AnyCable Go. And that's one of its features. And I would like to keep it. So that's why we should deploy AnyCable Go separately, similarly to how we deploy a database on Fly, for example. So it's going to be a separate application which we deploy once and just use it as a sidecar service. For that, we're going to call Fly launch again and specify the Docker image this time. So we're not going to automatically build, infer that configuration, that Docker file, whatever. We're just gonna use an existing Docker image. So it says we already have fly.toml, yeah, but we don't want to copy it. We looking for a new Fly configuration. App name, let's go with cable, just cable, why not? No, we don't need a database. Would you like to deploy now? I don't think so. We just want to take a look at the configuration. And for that, we can now save the configuration generated by Fly for this application to our host system to a separate toml file. And for that, we can use fly config save command. Just need to specify the app name, cable. No. Okay. And it seems that it doesn't create anything. Well, that's that's bad. I thought it's gonna save it to a config path I provided to it, but it doesn't seem to work like I expected. Okay, let's do a quick hack and call again. And yeah, we have a fly config in the temporary directory and just move it. Anycable.toml. So yeah, now we have a separate configuration for a separate application, our Anycable Go application. So what do we want to check here? First, concurrency. Of course, let's do 5,000 maybe. Why not? We don't need HTTP. We just need SSL. What else? We need to specify env to connect it to our application, probably. What kind of env do we need here? We use disconnectless, RPC-less Anycable setup. If we take a look at our local development setup with Docker, we have TurboRails key and JWT ID key. We should probably specify host and port variables as well, and disconnectless debug. Let's do that and copy to our production. So our host, to make it accessible from the outside, that's required for any containerized development. Secret and JWT ID key. Redis URL. Let's not add it for now. And disconnect disabled. Yeah, true. So TurboRails key and JWT ID key. Let's take a look at our configuration for Anycable. So JWT ID key is available here. So we don't need to worry about it, but our TurboRails key is hard-coded right now in the configuration. Let's copy it to the production environment to make it the same. We don't care about security right now. Ideally, we should put it in the credentials. And finally, Redis. So we already set Redis URL for the base app, and we can just do the same for Cable app. Same Redis URL. I think that's enough to deploy the app. Config fly .anycable.toml. Let's update our Rails app configuration. Here we now want to specify Anycable, and also we need to specify cable URL, which should point to our cable fly dev cable, and it's deployed. Let's deploy our Rails application with the changes. Okay, it's been deployed. Let's check that we're now running Anycable. And we can do that by looking at the network tab. Okay, headers, cable fly, and we have response X Anycable version. Right. Okay, we're now running Anycable. Let's make sure we're running it here as well. Any. Yes, great. So we are on Anycable. There's just a few additions, right? Just to separate TOML config, and that's it. So let's do benchmarking. We don't need to change anything in our setup because we infer the cable URL from the HTML page, from the metatext, just to remind you. Okay, let's run. $500. No problems yet. Let's try to squeeze. Okay. Now we started looking at the problems, right? And it seems that this is HTTP problem. Our Rails server cannot serve web pages. Okay. Let's scale further. Not that bad. Rails server is overwhelmed. It's just a single process server, so do not expect a lot from it. Okay, I think, yeah. So we were able to create almost 700 sessions. The timing is amazing. So the max is 100 milliseconds. If you remember, the results for Action Cable were like average was about like that, and it was seconds for max and P95. So subscription time is also perfect, and yeah, we see that HTTP failed a few times. Now let's take a look at our monitoring dashboards. Well, this is our cable app. Okay, nothing interesting here. Our logs are just empty, just starting logs, no errors, no warnings. And our metrics for the last 5 minutes. And we see that we really reached 2,500 concurrent connections, a lot of data transfer, which is expected. And this is our memory and CPU usage. It's like really low in both dimensions. We just used half of the available memory to handle 2,500 connections, like less than 120 megabytes. This is perfect, I would say. And yeah, everything went well except from the Rails app, which experienced some problems with HTTP, but not that big. Just about 1% of requests fail. So this is our RPC-less version of AnyCable. And we see that it works perfectly in our use case. So for hotwire applications, deploying AnyCable Go separately just solves all the problems. And you can scale up to, I would say, 5,000 connections, simultaneous connections at peak times with just a single AnyCable Go server on fly.io, which is amazing. Let's talk about how we can add RPC to the equation. And the simplest option here would be is to just embed AnyCable server into Rails application. Is AnyCable embedded true. We also need to configure our AnyCable RPC host to be 00151 just to make it accessible from the outside. And I think that's it from the Rails app side. Let's deploy it. Next question is how to specify AnyCable RPC host here to locate our RPC server from the Rails app, a different Fly app. Let's take a look at the documentation and see what DNS capabilities does Fly provide. The specific top-level domain available within Fly network system called internal, and we can see the list of available domain names we can use. We can use like app name internal to locate all the instances in all the regions, or we can prefix it with a region name and locate only instances in a particular region, which is great for our use case. We want like New Jersey AnyCable Go to connect only to New Jersey RPCs. So since this is the kind of an internal DNS server, it resolves to multiple addresses, and we can use it along with gRPC client-side load balancing based on DNS. So our AnyCable Go would connect to all the RPC services within our regions, not only to a single one or like a first one or whatever. For that, we just should specify RPC host here using the DNS schema. And then our region is EWR anycasts demo internal. We haven't specified the port here. My bad. Let's try to deploy it again. Okay, it's been deployed. Okay, we see the logs. It's starting. Now the port is here. Let's reload. Everything seems fine. And now let's reload again to see the logs of our disconnect call. Yeah, here we go. Finished. This is the RPC logs from our RPC server. So we see that the connectivity is here. So our RPC server currently embedded into Rails server is available and we can use it. And that's good enough. again, for a single instance application, and we can use that. And talk about one more bonus thing. So we learned how to deploy Anycable with RPC or without to Fly, and only using free instances. And we kind of load tested it, and we see that it works great. Now, want to learn to squeeze more from Fly and try to use their metrics feature. So Fly provides Prometheus server out of the box to collect your custom metrics. All you need to do is to add a metrics section to your fly.toml. This is custom metrics. This is what we need to do. Anycable Go provides Prometheus metrics exporter out of the box. So let's try. This is our Anycable Go. Let's create metrics section. We can use default here. What we need to add to Anycable is Anycable metrics HTTP. This is the path to metrics, and Anycable metrics port, which is going to be 9091. And let's deploy it. To collect some metrics, let's perform our case 6 test one more time for a shorter period. Let's scale it to 40, and 100, and now 400, and just wait for it to finish. To open our Grafana dashboard for our organization, which is important because Fly metrics by default use your personal organization, we should go to the app metrics section and just go open in Grafana. So yeah, here we have some built-in dashboard for our application. We see only one region available and so on. And I already uploaded a dashboard for Anycable, which is available here, and we can see, oh, this is our benchmark. This is when we added 400 clients, and there's our disconnector RPC code, which were executed after all the clients got disconnected. Yeah, they're executed not at the same time, but during some time frame to avoid hitting RPC server a lot. So this is what we got with Fly, and this is amazing. So we were able to deploy our Anycable application, which is not the simplest piece of infrastructure, right? It requires multiple components like WebSocket server, Rails server, RPC server. But we were managed to do that by just using a couple of configuration files. And then we were able to benchmark it and see that it works great. And even more, Fly now supports Prometheus metrics and building Grafana dashboards. So we can add custom monitoring to whatever point we want. So we can learn a lot about our application, do whatever we want. I say learning from Fly is really great. It was a great experience for me. And now I will definitely consider this platform for future Rails and Anycable projects. And probably we're gonna add some specific features for this platform if our users are interested in it. So see you next time, and let's fly.